But this little lab is going to demonstrate how forces affect each other and how we can demonstrate and represent those forces with arrows. And we're going to do that with these two marbles. Now I've got some blue paper here, and I'm going to coat this marble, the large marble. I've got two different sizes. I'm going to coat the large marble with some soap. I'm going to put it right in line with the ramp. And it's going to be stationary. So its mass is pretty large compared to the small one, but it has no acceleration at this point. Now I'm going to take this smaller marble, I'm going to coat it also with some soap. The reason I'm coating it with soap is that when I let this small marble slide down this ramp, it's going to have a small mass, but a large acceleration as it comes down the ramp. So it's going to actually have a force. It's going to bring a force into the system. Whatever force is applied to the system has to be the same force that is left after the system that leaves the system. That's one way of putting it. So let's see what happens. And with this soap on there, we should be able to track the distances that these marbles travel. Now the acceleration is going for the small marble as it comes down this ramp is going to pick up acceleration from the ramp, this entire ramp distance. And let's just see what happens. So what we have now are some lines on our paper that demonstrates the forces that were involved in this little demonstration. We had a force of the little marble coming in, and let's just represent all of the force of the little marble coming in this much. It had a large acceleration as it rolled down the ramp, and a little mass, and as it hit the big ball then had a big mass but a small acceleration. It wasn't rolling very fast. If you remember, it rolled kind of slow. And so it had maybe a force of this much, but not only did it have a force, to make these equal, I need to make this one the same size. The force that came in was also the same that went out. Now we know that also that there was a little bit of a bounce back on the little marble. So really to get these forces right, what I'm going to need to do is make this side of these two right here are the resultant forces. So these two added together needed to equal the distance. The one coming in, this one coming in, is equal to these two coming out of the system. So these two needed, this one needed to equal these two in size and length. So that kind of gives me an idea of how I can draw arrows. This is the main purpose of this demonstration, is to show you how to draw arrows representing the forces involved in a system.